This is the problem-solving session of the lecture. So I won't do whole questions, I'll just do pieces of them, just to illustrate techniques. And alright, so you're given two permutations of S5, so a symmetric group of 5 objects, A and C. So A is 1, 2, 3, 4, 5, and they permute 2. 1 goes to 5, 2 goes to 3, 3 goes to 4, 4 goes to 1, and 5 goes to 2. And a second one, C, and it's of this form. Write this out a bit faster. So 1 goes to 5, 3, 2, 4, 1, and you're asked to find what is A C inverse. Okay. Now remember the order. In general, if you take two permutations and you perform, let's say, permutation A and then perform permutation B, in general, the result that you'll get, the resulting permutation, will be different from if you perform B first and then A. So typically, permutations do not commute. Right? AB is generally not the same as BA. Right? So that means that you have to be careful about which one you apply first. So it's order dependent. So the convention is that the first permutation that you apply is on the right. So in other words, we will calculate first what C, well, we need to calculate what C inverse is. We know what C is, we don't know yet what C inverse is. We'll get the answer, and then we will perform the second permutation, A, this one, on whatever C inverse is. Okay, so what is C inverse? So C inverse. Now, we did this, I think, once or twice in the theory part. Now, remember, what is it? The inverse, what does it do? It takes you back. So if you do C, and then followed by the permutation C inverse, that will take you back to the unit inverse, right? So you can almost do this from inspection. So if C takes 1 to 5, you want the inverse to take 5 back to 1. Right? Seem reasonable? Okay, so you can write that down. You want 1 goes to 5, so 5 will, C inverse will make 5 go back to 1. So hence, when you multiply these two together, the net effect will be 1 will go to 1. Right? And that's part of the unit permutation. All right? 2 goes to 3. So you want 3 to go back to 2. Okay? 2 goes to 3, so you want 3 to go back to 2. 3 goes to 2, so you want 2 to go back to 3. Constant problem of drying pens. Okay, 2 goes to, what did I say? 2 goes to 3. 3 goes to 2, so you want 2 to go back to 3. 4 goes to 4, no change, so you don't have to do anything, right? So that only leaves 1. So 5 goes to 1, so you want, I've done that. So what are we left with? 5 goes to 1, so you want 1 to go to 5. Okay, so there's the inverse. We now have C inverse. All right, now multiply so now do AC inverse. I won't write this out again. Just imagine this A is here, and we're doing this one first. Okay, so watch how. This is how to multiply, in a sense, two permutations. Okay, so 1 goes to 5. I'll write this down. So A of this will be 1, 2, 3, 4, 5. Alright. So we're doing CA, this is C inverse, this is here, and then we're applying the second permutation, which is A, and we write it here on the left side. So this is the first permutation, this is the second. Okay? Alright? So we did this one first and then this one. Okay, so 1 goes to 5 and 5 goes to 2. So the net effect is 1 goes to 2. Right? 2 goes to 3 and then 3 goes to 4. So the net effect is 2 goes to 4. Alright, 3 goes to 2 and 2 goes to 3. So 3 goes to 3. So no net effect. 4 goes to 4, 4 goes to 1. So 4 goes to 1. And 5 goes to 1 and 1 goes to 5. Alright, so there's your answer. Let me just check in the answer section of the book that I haven't made a stupid mistake. 24315. 24315. That's correct. Alright. Alright. So next question I'll do is you're asked to find the number of reversals, number of reversed pairs. And I'll only do one example, and again it'll be for A. So find the number of reversed pairs for this permutation. Okay. In other words, you're asked to find n. I'm getting a new pen. Find n. You probably can't see it. I'll write it again. Find n of A. Okay, so that's what you're asked to do. So, right. So we have to find the number of reversed pairs. Reversed pairs. Okay. Well, firstly, what are all the pairs? You remember, you take any. You take two of the upper row, I and j, but I has to be less than j. So, how many possible pairs do we have here? Well, we can have 1, 2, 1, 3, 1, 4, 1, 5, 1, 3, 1, 4, 1, 5. Right? Now, what's some more pairs? Well, we could have 2, 3, 2, 4, 2, 5, 2, 3, 2, 4, 2, 5, and then we could have 3, 4, 3, 5, 3, 4, 3, 5, and finally 4, 5. Okay, so that's the limit. That's the total number of possible pairs of this form. These I and j come from this row, and i's got to be less than j. Now I think the total is 10. It should be 10, right? 4 plus 3 plus 2 plus 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. Now the next thing is you have a look at, if you permute the I, whatever it is, one of these 5 numbers, if you permute it with the permutation x, in this case A, okay, so, well, yeah, we could put A here, right? So for each of these I and j, permute it by the permutation A, this permutation. All right, well, let's do that. So we will get let's see. Okay, so 1. Now it's it's this one. All right. So much easier to wipe up now with the new board. Great. Okay, so so 1 permutes to 5. So wherever I've got a 1 here, just put a 5 there, so I'll do that systematically. Okay. Alright, now 2, what is A of 2? So 2 permutes to 3. So where I've got a 2, put 3. Alright, now 3 permutes to 4. So where I have a 3, put a 4. Okay, 4 permutes to 1, so where I have a 4, put a 1. Right, and 5 permutes to 2, so where I have 5, put a 2. Okay, now a reverse pair. Now of these 10, how many reversed pairs do we have? What do you mean by a reversed pair? That means that A of I is greater than A of J. See, I is less than J, but after the permutation, after you permute with this permutation A, if A of I is greater than A of J, that pair, that IJ pair, is said to be reversed, right? Because this is larger than that now, rather than smaller the way it was before. The ordering, the greater than or less than, has now been reversed, so it's called a reversed pair. So we now look at these 10 and just put a tick, let's say, how do you say it in American? Tick? You see, I've lived in 3 English-speaking countries: Australia, England, America. And sometimes I'm not quite sure which word that I use is from which of those 3 countries. So, anyway. Okay, so now check these for the first one, A of I, being greater than the second one. And if it is, it's a reversed pair. Well, that's obviously a reversed pair. So's that, so's that, so's that. No. Yes. 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 Okay, so we've got 3, 4, 5, 6. We've got 8. So N of A is 8, right? We have